In this section, we're going to start talking about the next application that we're going to put together. This next app is going to be kind of small in nature, but we're going to cover a rather complicated subject. And I think you're going to end up liking it quite a bit. Okay, so here's what we're going to build, a little animation. So we're going to figure out how we can put a little animation together using some of the absolute core widgets inside of Flutter for building animations. The animation we're going to build is going to be a little cat in a box, more or less. So before I tell you too much about this mockup, I want to show you a quick animation of essentially what we're trying to build inside of Flutter. All right, so this was a little animation that I saw over on codepen.io a little bit ago. It's created by Jennifer Perdomo. She's the original author. I thought it was a really cute animation, and I thought it'd be something interesting to put together ourselves. So this animation plays exactly one time when this page is loaded up inside the browser. So I'm going to refresh it right now, and you'll see the animation. Okay, here it goes. So when the animation starts out, the cat's out of the box, it goes into the box, and it comes back out. Pretty straightforward. Now we're going to do something very similar to this, but with a couple of little changes or little tweaks. So when a user first loads up our application, we're going to show the cat inside the box. So all you're going to see are the ears peeking out at the very top. While the cat is in the box, we're going to have these two flaps over here on the left and right hand sides, just kind of shaking left and right a little bit to kind of simulate the cat in the box playing around in shaking the box. Then anytime a user taps on the box, we're going to stop the flaps from shaking, so they're just going to instantly freeze in whatever position they are in, and we're going to animate the cat very smoothly rising up out of the top of the box. And then if the user taps on the box again, it's going to go back to the initial state. And so essentially there's two states here. Either the cat is in the box or it is out. And while the cat is in the box, we're going to have these flaps on the left and right hand sides just shake a little bit. So like I said, it's going to be a cute and fun little animation, and it's going to give us a better idea of how animation works in Flutter in general. So before we get started, we're going to generate our app over at the terminal. So I'm going to flip on over to my terminal. You'll notice I'm again inside my workspace directory. Inside of here, I will generate this new project by running Flutter, create, and then we'll call this thing just animation. I think that's reasonable. Okay, so that's going to install some dependencies. Now in the next section, I'm going to start up my terminal, or my simulator, and I'm going to run the app inside of it, and I'm going to open my code editor as well. So go ahead and let the install run, and then run it on your simulator, and open up your code editor, and we'll be ready to go in the next section. In the last section, we took a look at a mockup for the next application we're going to build. We then generated a new Flutter project, and hopefully between the last section and this one, you started up your emulator and executed Flutter run for the new project in your terminal. You'll notice that I've also already started up my code editor. Make sure you do the same as well. All right, so back to our diagram over here of what we're going to be building. So again, it's a cat animation. In this section, I want to talk a little bit about the different parts of the animation API that we're going to use to build out this animation. Now, in the next diagram I'm going to show you in just a second, I'm going to list out a couple of different core classes in the animation module of Flutter. We're not going to look at the documentation around these different modules too closely, just because we would have to be flipping around between a ton of different pages. So I want to first show you where you can look up the documentation for all these different classes we're going to talk about on your own if you are at all curious. So again, I'm at docs.flutter.io, and on the libraries listing up here on the top left-hand side, the first entry that you'll see is animation. So inside of this animation module is everything having to do with animation that we're going to be working with. So on here on the right-hand side, you'll see, say, the animation class. So again, feel free to take a look at the documentation as we go through this next application. I'm only going to refer to it in like a couple of very choice locations. All right, so with that in mind, let's talk about how we're going to use that module to create this animation right here. So here we go. Okay, each of the blue boxes that you see on here represents a different class inside of that animation library. So there's a class inside there called animation. There's another class called Animation Controller, Tween, and Animated Builder. And these all have a place inside the process of animating some element. Now, before we dive into the purpose of any of these too closely, there's one thing about the animation that I want to point out in particular, because it's going to kind of frame all of our discussion about this stuff. As we were just talking about the animation and like what's going to happen on the screen, there were clearly maybe 2 or 3 distinct parts of this animation that are going to move around. So obviously the first one is the cat. The cat right here is going to kind of come up and down out of the box. So it starts off down here low, and then as soon as the user presses on the thing, the cat is going to very slowly, or maybe quickly, I don't know, we'll see how the timings work out, but the cat is going to rise up out of the box. And so the cat is going to essentially move from some initial state down here, and then it's going to move vertically up out of the box. So that's kind of like a vertical movement of this little cat right here. Now the other part of this animation that's moving around are going to be the 2 folds on either side, kind of like the flaps on the box. Now for this initial discussion about animation, I want to first focus just on the part of having the cat move from being down in the box to up, right? Like up, popping out of the box. So since that is the only part of the cat that is going to kind of move or change over time, we would refer to the animation of this cat element right here as being a change in its vertical position. So what you and I really want to do to create this animation is somehow figure out how to animate or change over time the vertical position of this cat right here. Okay, so just keep that in mind as we start to talk about some of these different classes. So the first 3 that you see listed on here are all about somehow defining the process of having the cat start down low and then move up to the top. It might seem like overkill to have 3 different classes just to record that fact of like, hey, here's the current position of the cat. I kind of agree. Having 3 classes just to get the cat from being down low up high, kind of overkill, but that's the way the animation API here works. Now the 4th class is the first one we're going to actually talk about because it's the one that's going to probably seem the most familiar. So the 4th class on here is called an animated builder. This is a widget that is going to take the description of an animation and a function that we'll refer to as the builder function. The animated builder's purpose is to look at that animation, watch as it changes over time, and then every time that some given animation starts to change, it's going to rerun that builder function and update some widget on the screen of our device. And so that might sound very familiar to the stream builder that we spoke about earlier when we were starting to work a little bit with blocks. Remember that stream builder, we passed it a stream and a builder function. Every time that stream had a new value come across, the builder function would run and then change something on the screen of the device. And so you can think of this animated builder over here as being almost identical in nature to the stream builder that we worked with earlier. Okay, so that's kind of the easy one to understand because very similar to something we've already worked with before. So let's now go all the way back over to the left-hand side and talk about the animation class. So the animation class's purpose is to record the current value of the property being animated. So this is why this vertical position thing starts to come into play. So again, the position of the cat, or like its vertical position, is probably going to be the property that you and I want to change over time. Starting from some initial time when the user like first taps on the box to like 1 or 2 seconds later when the animation completes, the only property that we're changing around the cat is its vertical position. So you and I are going to create a new instance of this animation class, and it's going to store or essentially record what the current vertical position of that cat is. Is it all the way down at the bottom? Is it all the way at the top? Is it halfway in between? The animation class is going to store that information. The animation class is also going to record the current status of the animation. So whether it's currently running, like it's in the process of moving up to the top, or if it has not started at all and the cat is still in the box, or if the entire animation has been completed and the cat is now all the way up out of the box. So in total, you can kind of think of this animation class as storing what you see down here inside the gray box. It's recording the status of the animation, whether it's stopped, running, or not even began, and a property that is going to change over time. And so for you and I, maybe it's the Y position or the vertical position. The vertical position of the cat is going to change over time. Okay, so that's the animation class. Next up is the animation controller. Now, as I start to talk about the animation controller, it's going to really sound like it is very closely related to the animation class. And in fact, yes, it is. Again, these first 3 classes right here, all very similar in nature. So the animation controller class is going to be responsible for starting, stopping, or restarting the animation. So yeah, that sounds real similar to the animation, right? The animation knows whether it is running, stopped, or hasn't even began yet, but the animation controller is going to be responsible for actually changing the state of the animation. Essentially, you can imagine the animation over here as being like a to-do list, and it's got like a couple of different properties written out on it, and it only records some amount of information. To actually change a to-do list, you and I have to take like a pen or an eraser and cross a line out or add a new record or a new to-do inside there. And so you and I would be like the animation controller. The to-do list itself would be like the animation. So the animation controller starts, stops, restarts the animation. And then interestingly, it also records the duration of the animation as well, like how long the animation is going to play. Now this is another property that kind of sounds like it should belong to the animation, but again, for whatever reason, it does not. So the animation controller knows about how to start, stop, restart the animation, and it knows about how long the animation should take. And so on the animation controller, you can imagine that we have a couple different properties like duration. It might be, say, 1 second. That means it's going to take 1 second to play the entire animation. And then maybe it has some methods tied to it like start to start the animation or stop to stop the animation in place. Now the third class that you and I are going to work with is a class called Tween. And Tween right here is kind of like a play on words, kind of short for the word between. So it describes the way in which some animated value is changing, or more precisely, the range of values that our animation is going to span. So yet again, Tween seems very similar, very closely related to the animation. The animation just records the current value, but the tween is what describes the range of that value. So for you and me, let's imagine that the cat starts out inside the box with a vertical position of, say, like 0 pixels. The cat is, by default, 0 pixels out of the box. And then over time, when the animation plays and the cat comes all the way out, maybe the cat is now 200 pixels vertically moved or translated up the screen. And so our tween would be created with a starting value of like 0 pixels and then a final value of 200 pixels. So again, the tween describes the entire range of values that our animation is going to span. And yeah, that's what I reflect down here on the gray box. And then we already spoke about the animated builder. So hopefully the animated builder makes a little bit more sense right now. An animated builder is going to take an instance of the animation, and then whenever the value tied to the animation changes, boom, animated builder is going to rerun. All right, so that's a quick overview on some of the different classes we're going to work with. Honestly, my opinion is about all this animation stuff that the real complexity around animations is just understanding all these different classes that are floating around. Doing the actual animation, not the worst thing in the world. It's all these different classes that you and I have to work with that makes life a little bit of a pain. All right, so now that we've got a better idea of what's going on here, we're going to take a quick pause. We're going to come back to the next section, and we're going to start building our application inside of our editor. So again, do make sure that your editor is up and ready to go. So quick break, and I'll see you in just a minute. In this section, we're going to do a little bit of massage on the default code that we get whenever we create a new project. So as usual, we've got our main.dart file right here, and we've got a bunch of code inside of it. So as usual, I'm going to highlight everything inside of here and delete it all, and we'll start off from scratch. So inside this file, we're going to import the material module from Flutter. We're then going to attempt to go ahead and create a new instance of our app and then run that app. So let's get to it. Inside this file, I will import package Flutter from material.dart. I'll then define my main function, and inside there, I'm going to call run app, and to that, I will pass a new instance of my app. Of course, we have not yet created the app, but I'm sure that we will do so in just a second. So I'm going to first create an import for the app that we'll create in just a moment. I'm going to assume that we're going to define it inside of a src app.dart file. And then I'll create that folder and that file right away. So inside of my lib directory, I'll make a new folder of src, and I'll make a new app.dart file inside there. All right, so inside of app.dart, I'm sure you can guess what's going to come next. At the top, I'm going to import package flutter material.dart. We'll define a new class called app, that's going to extend stateless widget. Inside of here, we'll define our build method that's going to take some context and return a value of type widget. And then inside there, we're going to make a new instance of a material app. And we'll give it a couple of different typical properties, like a title. How about animation? I'll give it a theme of theme data with a primary swatch of colors.blue. And then finally, we'll define our home route. So we'll say home is going to be a new widget that we'll create again in just a second. We'll call it home. And I think we can basically leave it right there. Oh, let's add the import statement for home at the very top first. So I'm going to import, how about we'll say that we're going to have a new directory inside of here called screens. And from there, I will get the home.dart file. Okay, so just a little bit of typical boilerplate. So let's take a quick break. We'll come back in the next section and we're going to start putting together this home widget. So I'll see you in just a minute. In the last section, we started putting together a little bit of boilerplate for our new animation application. We'll now continue by creating a screens directory and making a home.dart file inside there. So inside of my src folder, I'll make a new folder called screens. And then inside of screens, I'll make a new file of home.dart. And then inside of here, we'll put down our typical import package, Flutter, material.dart statement. And then inside of here, I'm going to make a class home. And you might be expecting this thing to extend a stateless widget. Instead, we're going to kind of do things a little bit crazy. And I'm going to make this a stateful widget instead. And then as you recall, to make a stateful widget, right underneath our initial class right here, we have to make a home state class that is going to serve as the actual class that holds the state inside of this overall home widget. So this is going to be extending state of home. And then we'll just leave it right there for a second because I want to first have a quick discussion on why we are making a stateful widget at all. Okay, so here's a quick diagram. Not exactly of the application we're going to build, but I want you to imagine for just a second that this is what we are making. So at this point in the course, we've said several times, oh yeah, for managing data or state inside of our application, we're going to create a block, and that block is going to be responsible for holding all of our data. But we just made a stateful widget. So why is that the case? Well, here's the thing. The block that we are going to make for most applications is really concerned with holding application level state. So some description of maybe the different tweets that we've loaded up, or the values in some form, or maybe a list of images that we need to display on the screen. It's all about data that is relevant to our entire application. But what you and I are building right now, like a simple animation right here, this animation is going to have some data tied to it, or specifically kind of these instances of animation controller in Tween, that are going to contain data that is not relevant to any other part of our application. Chances are that any other part of our application doesn't really care about whether this cat is like halfway up out of the box, like right there, or all the way out. Chances are no other part of our application really cares about that. So when we put together animations, even if we're using a block pattern or some other type of state management pattern inside of our application, we'll typically store all the data related to this animation inside of a stateful widget that is housing the actual animation process. So in this diagram right here, I reflected that as being kind of like a child of the home. For you and me, we are going to make the home widget a stateful widget. I just kind of arbitrarily changed the diagram right here to make it kind of clear that, hey, some animation that exists right here, chances are the login screen doesn't care about the state of that cat. So that's the entire idea here. So with that in mind, we do want our home class right here to be a stateful widget. So inside this thing, I am going to go through the process of making a typical stateful widget. So I'm going to add a create state method. Anytime someone calls this thing, we're going to return a new instance of home state, like so. And I'm also going to annotate the return type of that function as well. just for fun. Then inside of the home state method, we're going to make sure that we define a build, or excuse me, the home state class, we're going to define a build method that's going to return something of type widget, like so. And let's not forget that context argument as well. Okay, so that's good for right here. Now that we've got a better idea of why we're making a stateful widget, again, it's because chances are nothing else inside of our application probably cares about the state of our animation. Let's take a pause here. When we come in the next section, we're going to start talking about how we create some of these different classes inside of our new home state. So quick break, and I'll see you in just a minute. In the last section, we created a stateful widget to represent the home widget of our entire application. Again, we made this a stateful widget because it's going to house some data about the current status of the animation, and chances are no other widget inside of our application is going to really care about that. So now that we've got our home state class put together, we'll start to flesh out our build method. So inside of here, we're still going to return some typical things that you would expect to see inside of a normal application. So I'm going to return from here a scaffold that's going to have an app bar. I'll give that app bar a title of text. How about something like animation? And then for the scaffold, I'm going to give it a body. Now, as we start to put this animation together, you're going to see that there is a tremendous amount of nested code and nested widgets that we're going to have to define. And so as much as possible, you and I are going to try to define all the different parts of this animation in separate helper methods inside of this home state class. The idea behind this is that it's going to keep all the code inside of home state very legible compared to if we just added all the code directly to this body property right here related to the animation stuff. In other words, as a quick example, you and I do not want to end up with something that looks like this. We don't want to do something that's like animation, takes an animation, takes an animation, takes an animation, like so on and so on. Because that very quickly gets extremely hard to read. So as much as possible, we're going to break out all these different widgets into helper methods inside this class. So starting first with this body right here, rather than placing an actual body, we're going to create a helper method called build animation. And that's going to be a method that's going to return kind of like the core elements of our animation. So inside my widget class, I'm going to immediately make a method that returns a widget called build animation. And then we're going to start to do a little bit of work on the animation itself inside of here. And then very quickly, we will create a couple more helper methods inside of here to kind of further break up the structure of this animation. Okay, so another quick break. We'll come back in the next section, and we're going to start putting together the code to get a cat by itself on the screen. In the last section, we put together the build animation method, which is where we're going to put together a lot of code to actually lay out all the different widgets that form our animation, and then somehow apply our animations to them. Now, to get started with, we're only going to render an image of our cat. So, in other words, just this part right here. And to begin, we're going to focus on just getting that cat by itself to move around the screen. Once we're able to do that, we'll then add in the box and the flaps on either side. So to get started, rather than actually building the cat image widget directly in here, I'm going to make a helper file, which is where we're going to locate the image itself, and then we'll import that into our home state file, or the home file, and then we'll show it from the build animation method. So to show the cat on the screen inside my src directory, I'm going to make a new folder called widgets, which is going to house all the reusable widgets that we create inside of our application. Then inside there, I'll make a new file called cat.dart, and as you might imagine, sole purpose of this file is to show an image of a cat on the screen. At the top, I will import package Flutter material, and then I will make class cat extends stateless widget, and I made a typo in here. It should be, material.dart, like so. Then inside of this widget, we'll define our build method that will take our context, and from there I'm going to return an image that pulls its source off the internet. So remember, that will be an image.network. Okay, and then inside of here, we're going to put the URL to the image that we're going to use. So I've already created an image for us to use and uploaded it online. So the URL of the image that we want, I'll put on the screen nice and large in just a second, but as a quick preview, here's the image. So it's really large. Let me zoom out really quick. So it's all black with a black background. The black background is not going to show up as black on our device. On our device, we're going to just see the outline of a cat, which you might be able to see on the screen right now. So let me put the URL on here for you. There we go. So please triple check your spelling here. Notice that the capital letters inside the Q, W, H, Z, R, Y, L are all case sensitive. So make sure you get a capital Q right here, capital Z, capital R, capital L on the end. Okay, so that should be it for our image. I will save this. And then we'll flip back over to the home.dart file, and we'll show this cat from that build animation method. So back inside of home.dart at the top, I'm going to import going up one directory, so up into the src directory, and then into widgets, and then I will get cat.dart like so. Then down inside of build animation, I will return cat. All right, so quick save, and we'll do a quick test. So I'm going to do a full refresh. Now, I have an error over here. You probably will not have an error. Don't worry about this just yet. Let me just do the restart real quick, and we'll make sure this thing works as we expect. Okay, there we go. And we get the cat nice on the screen. Perfect. So another quick break. We'll come back to the next section. We're going to start diving into those different instance or those different classes that we were just talking about. So all these right here. We're going to set these all up inside of our home widget, and then apply them to the cat that we just got to show up on the screen. So quick break, and I'll see you in just a minute. In the last section, we got our actual cat image to show up on the screen. So for right now, we're not going to be worried about the box. We just want to get this cat to essentially move up and down the screen whenever we tap on it on the emulator. So to get started, we're going to start to create some instances of the animation class and the animation controller inside of our home state class. So back over here, I'm going to first declare two new instance variables and associate them on the home state class. The first one is going to be an animation. Now the animation class right here is a generic class. Remember, a generic class has the ability for us to kind of specify the type that's going to be worked with inside this class on the fly. Our animation class for animating the position of our cat on the screen, so it's kind of vertical position up and down, is going to have the animation value that we're going to change over time be a double. So it's going to be essentially a number that you and I are going to change to control the vertical position of the cat. So I'm going to mark the animation class right here as controlling a value of type double inside of it, like so. And then I'm going to call this the cat animation variable. So remember, this right here only does an initial declaration of the variable. It doesn't actually initialize it to any useful value. So we're going to take care of the initialization step in just a moment. For right now, we're just going to declare these instance variables and the type that they are going to be. So besides the cat animation, which is going to be of type animation over here, we're also going to create an instance variable that refers to the animation controller that will be responsible for moving the cat around. So underneath the cat animation, I will also create an animation controller that I will call cat controller, like so. Okay, so again, these two statements right here just declare the instance variables. They do not actually initialize them or set any useful value to them. So we need to define some location inside this class where we're going to do that actual initialization. To do so, I'm going to create a method inside of here called initState. Now the name of this method is not something I just made up off the top of my head. This is what we refer to as a lifecycle method. Anytime a new instance of home state is created, if you and I define initState, it will be automatically invoked for us, which makes it a perfect place to do some initial setup of the different variables that we defined inside of our class. The initState lifecycle method is only available for classes that extend the state-based class. So if you and I define initState up here inside of some other method or some other class that does not extend state, this will not be called. Again, init state is very special, very particular to the state base class. So I'm going to clean this up here because it would never be called. Now inside of here, you'll notice that there's a green squiggly, and if we hover over it, it says that this method overrides something annotated as must call super. So the init state method is actually defined on the base state class. If you and I want to redefine it here, that warning right there is saying that we have to call the original implementation of init state that is defined on the base class of state. So to do so, I'm going to add on here super.init state, like so. And then that warning goes away. Okay, let's do a quick pause right here. When we come back to the next section, we'll do some further initialization of cat animation in cat controller. So a quick break, and I'll see you in just a minute. In the last section, we declared the cat animation in cat controller instance variables, and then we set up the init state method, saying that it would be a perfect place to actually initialize these two variables now. We also had to call super.init state in there because the base class of state had an existing implementation of init state that always has to be called. All right, so now inside of here, we're going to do a little bit of work to set up both the cat animation and the cat controller. We're going to first set up the cat controller. As a quick reminder, the cat controller is going to be responsible for starting, stopping, restarting the animation, and it also is going to record the duration over which the animation is going to run. So back over here, I'm going to say that cat controller is going to be an instance of animation controller. And then inside this thing, we're going to pass two named parameters. The first one is going to be a duration, and like we just said, this is the duration over which we want the animation to play. So to get started, I'm going to provide a duration of seconds 2.0 like so, excuse me, just 2 like so. The duration class describes a duration of time. It has several different name properties that we can pass in, one of which is the seconds name parameter. So this line right here is saying that we want our animation of the cat kind of raising up and lowering back down to play over a period of 2 seconds. Now the second name parameter that we're going to pass in here is going to be a little bit more mysterious. Okay, so we're just going to add this parameter in, and then we'll go take a look at some documentation and get a better idea of what this thing does. So I'm going to add in vsync is this, like so. Now when I add that in, you might notice a little red underline right here, which is totally fine. We're going to fix that up in just a second. First, let's go and take a look at the documentation for animation controller and get a better idea of what this vsync thing is. Okay, so I've still got the animation library documentation up. Remember, you can get here by going to docs.flutter.io. So inside the animation module, I'm going to find the documentation for animation controller. Here it is right here on the right-hand side. And then as usual, we'll scroll on down to our constructor. Here's a constructor right here. And you'll notice that there has the name parameter of vsync, and that parameter has this @required thing on it. And so anytime you and I create an animation controller, we are provided to pass in an instance of something called a ticker provider on the vsync parameter. Let's talk about what this ticker provider is by first looking at the documentation. Okay, so the ticker provider, if you want to, you can absolutely read all the documentation in here. Essentially what this ticker provider class does for us is give us a little bit of a notification anytime our animation needs to do an update. So sure, over here you and I specified the duration, but the duration doesn't just magically make the animation kick into play. Something has to actually reach in to our home state class and find this controller and tell it, hey cat controller, you need to look over at that animation variable, and remember the animation is storing the actual current value of our animation, and you need to update that animation's value. So the ticker provider is kind of like a handle from the outside world into our widget that gives the outside world of Flutter the ability to reach in and tell our animation to kind of progress along and essentially render the next frame of our animation. Now, getting the ticker provided added onto our class is going to be just a little bit challenging. The ticker provider itself is actually a mixin. So we're going to use that mix-in syntax to create a new ticker provider, or excuse me, not create a new ticker provider, but get our ticker provider mixed in to the class you and I are working on. So back over here, I'm going to find where I define my class. And then right after the extend state, I'm going to add on with, and then I'll say ticker provider state mixin, like so. Okay, so again, the ticker provider thing is what gives the outside world a handle into our widget and allows it to tell our animation controller that it needs to kind of progress along the animation for the next frame. Adding in vsync of this right here is essentially saying we just mixed in our ticker provider to our current class, or this instance of the class that we are currently working with. So passing in this on the vsync argument right here says, hey, we have a ticker provider and it's actually mixed in to the current class. And that's why we are providing it to the name parameter of vsync as simply this. Okay, so I know maybe this animation stuff is already seeming a little bit crazy. If it does, don't worry, trust me, as soon as we get through this entire example or this initial kind of cat animation, a lot of this stuff will start to come together and it'll make a good amount of sense. In addition, as we start to put more code on the screen, we're going to go a little bit more behind the scenes and get a better idea of, why we have the animation, why we have the animation controller, and why all these different pieces are kind of parted out. All right, but with that in mind, let's take a quick pause right here. When we come back to the next section, we're going to also start to define our cat animation variable. So quick break and I'll see you in just a minute. In the last section, we initialized our cat controller inside the init state method. So we now have an object right here that controls our animation. The cat controller is going to have the ability to start, stop, or restart the animation. The cat controller also knows about the overall duration of the animation as well. So now that we've declared and initialized our cat controller, we're going to do the same thing for our cat animation as well. So I'm going to write out cat animation. And now, unfortunately, initializing the cat animation is going to be a little bit more complicated than the animation controller right here. So you and I are just going to write the code out for this, and we'll very quickly talk about exactly what's happening. So let's get to it. I'm going to say cat animation equals tween. I'll say begin 0.0, end 100.0. I'll then put a new line in. I'll do an indent. I'll put a dot down, and I'm going to chain on a method called animate. Now, animate is going to have a couple of different arguments or passed into it, or I should say a single argument that's rather large. So I'm going to give myself a little bit of space to work with here. And then into animate, I'm going to pass curved animation. I'll open up another set of parentheses like so. I'll say parent is, cat controller. And I'll also pass in a named parameter of curve. And that will be curves.easeIn, like so. And that's it. Now I'm going to save this, and when I do, again, my code is going to jump to what you see right here. So we're creating our tween. We're then calling animate on that and passing in something called a curved animation. So let's first get started by talking about what we're doing with tween right here. So first off, let's look back at this diagram right here. Remember, the tween is a class that's going to describe the range of values that we want to animate over. Now, that's kind of hard to understand without getting a good diagram of understanding what we're trying to really animate over here. So let's take a look at this diagram right here. So in order to get our cat to essentially move up and out of the box, we're going to attempt to change the positioning of the cat over time. So the cat's positioning is the value that's being animated. By defining a tween with a begin of 0 and an end of 100, that essentially means that we're going to have the ability to start off with a vertical change of the cat starting at 0 pixels, and then over time, we're going to slowly animate this thing up to like 100 pixels in displacement up. So you can kind of imagine this thing going up, 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 until eventually it hits like 100 pixels right there. So that's the purpose of the tween with a begin of 0 and an end of 100. We're saying that we're going to want to have some number sitting around inside of our application that we can use to change the elevation of the cat from 0 pixels up to 100. So that takes care of the tween. The second thing inside of here is the animate function call, where we pass in something called a curved animation. Curved animation right here describes the rate at which our animated value is going to change. So we know that the duration of the animation is going to be 2 seconds, and we know that the animation is going to span from 0 up to 100. The curved animation describes how quickly the animated value is going to change from 0 to 100. If you mouse over ease in right here, you'll see a little chart like that right there. So this is describing the rate at which our animated value is going to change. The x value, or the x-axis right here, is time, and then the vertical axis describes the thing that we are trying to change. So this means that our value of the cat animation, like the vertical change in it, is going to start off changing very slowly, very slowly, very slowly, and then over time it's going to somewhat pick up the rate at which that vertical change is occurring. So if I went back over here to give you a more practical example of this, we can kind of imagine that with that ease in curve, we kind of start off with, here, let's go from right here. We can kind of imagine that with ease in, we're going from like very slow change, very slow change, very slow change, and then like halfway through it, at some point along, it starts to speed up and go faster and faster and faster, and then eventually towards the end, it's changing much more quickly than how it had first began. So the sole purpose of the curved animation right here is just to describe the rate at which we are changing this animated value. And in general, it leads to slightly better, or I should say a little bit more natural looking animations. We'll play around with the curve value right here, and we'll get a sense of how some of the different curves that we can use kind of change how the animation really looks on the screen. Okay, so the result of creating the tween and then calling animate right here is a animation object. And so we took that animation object and we assigned it to cat animation right here. So now that we've got our cat animation together, we'll continue in the next section where we're going to figure out how we can use the cat controller and the cat animation to actually change the positioning of our cat on the screen. So quick break and I'll see you in just a minute. In the last section, we put together our cat animation by creating a new instance of tween and then calling the animate function on it. When we call the animate function right here, it returns a value of type animation, which is what we had defined our cat animation to be. Now, one thing you might be a little bit curious about, back over on this diagram over here, we had spoken about how, yeah, we've got the animation controller, and the tween. However, we only declared instance variables for the animation and the controller. We did not declare an instance variable for the tween. The reason for that is that we are going to want to refer to the animation and the controller throughout other methods inside this file. However, we're never going to have to define, or reference this tween again. The tween is something that we create just one time and then we essentially throw it away and don't really use it again. So that's why we did not declare the tween and assign it to an instance variable. So now that we've got our controller and our cat animation put together, we can use it to animate the movement of our cat around the screen. So this is where that animated builder is going to come into play. The animated builder is a widget that takes an animation and a builder function, and then every time the animation ticks, and remember the animation is going to change thanks to it being poked by this ticker provider up here, the builder function will rerun and show a new value for our animation on the screen. So inside of build animation, rather than returning cat, I'm going to remove that, and I'm going to instead return animated builder. To the animated builder, we're going to pass in something for the animation. So this is going to tell the animated builder how it's going to change over time. So that's going to be our cat animation. And then we'll also pass in the builder function, which is going to be our context. And then as the second argument, we're going to pass in something called the child. And then I'll define the function body. Okay, so you're probably wondering about this child argument right here. I just said 2 seconds ago that, hey, yeah, we're going to like return some widget inside the thing. So the idea behind the child right here is that you and I might want to create a widget and then only change like one aspect about it over time. And we might not want to like recreate something from scratch inside of here over and over again, as we did previously with that stream widget. Remember when we made our stream builder, inside of there, we had our builder function that took that context and snapshot. And then from the builder function, we returned a brand new widget every time. Like maybe it was a text thing, and maybe it showed some value out of the snapshot, I don't know. But the point here is that every time the builder was called, we created a brand new instance of some widget and we returned it. Now in the case of a stream, that might be okay, because with the stream, we might not be trying to like change values that often inside of our application. Like in other words, how frequently can a user type in a form or type in some input, assuming that typing that input changes some stream? Well, a user can't type that often. But in the case of an animation, we're going to have an animation that's attempting to change itself 60 times a second. And so ideally, we would not be attempting to recreate some widget to show inside this animation 60 times a second. We don't want to keep trying to recreate this thing again and again and again and again. So to keep us from having to recreate some widget over and over and over again, we can pass in a third named argument to the animated builder. And the name of that argument is child. So right here, we can just declare a widget one time, and then inside the builder, we can save on performance by not recreating the child every single time. Instead, we can just try to like maybe change one small value about that widget. Or maybe we can attempt to only declare like one positioning widget maybe inside. So essentially, to the child argument right here, we're going to declare a new instance of our cat. So now we only have to create cat one time, and then that single instance of cat is going to be reused over and over and over inside of our animated builder. So now that cat is going to be the second argument to the builder function right here of child. Okay, let's take a quick pause right here since we've spoken about how the animated builder really works. We'll come back to the next section and we'll start using that cat that we created to position it on the screen by using our builder function. So quick pause and I'll see you in just a minute. In the last section, we spoke about how we use the animated builder. We first define a child right here, and then that child is going to be repeatedly passed into the builder function every time the animation updates. So that allows us to only create a child one time, and then inside the builder, we can make just small, tiny tweaks to that thing and avoid having to recreate a ton of different widgets. So let's write out the code that we're going to put inside of here. We're going to first just put the code inside of here, and then again, we'll talk about what it's doing for us. So inside my builder, I'm going to return a container that has a child of child, and then I'm going to define a margin that has an edge insets dot only with a top of cat animation dot value. Okay, so let's again, we're going to take a quick pause here, talk about what this does. Now, just a second ago, I said, oh yeah, inside of our builder function, we don't want to be recreating widgets over and over and over again. But clearly, that is what I'm doing here with the container. So here's the thing. Remember that at the end of the day, the only way that we can change the layout of widgets on our screen is by creating a new widget. Even when we make use of stateful widgets, as we are right here, remember how we spoke about much earlier when we started to discuss stateful widgets? We had said that the difference between a stateful widget is that the home state class right here is created one time, and then we hold on to that. But the base widget of class home right here gets recreated and thrown away again and again and again. So at the end of the day, it's kind of unavoidable to not create something again and again inside the builder method. The idea behind having the child property here is that if we have a really expensive widget to create, then at least we can only do that one time. And so at least in this case, we're only making the cat one time, we're recreating the container again and again, but that's okay. We'll recreate the container as much as we want because that is an inexpensive widget to create and throw away again and again. Next up, margin. So, quick diagram over here. So we're creating a container and we are passing in a margin. Now, I just put in a margin with a top property rather than bottom. We'll talk about why in just a second. But essentially, inside of our container, we're going to move this cat around by changing the margin around the cat. So we're going to start off with a margin maybe on the bottom, maybe on the top. We'll talk about why we did top in just a moment. Starting off at 0, and then as the animation plays, the builder method is going to be called again and again, and we're going to change where we are getting that top value from, or bottom, whatever. So it's going to start off at 0, and then go up to 10, and then go up to 20, and then 30, and then eventually end up at 100 pixels, or just the number 100. The reason it's going specifically from 0 to 100 is because, remember, that is what we started with our tween. So the tween starts at 0 and goes up to 100. Now, why are we using top right here? Well, eventually, when we put together the final animation, like our final copy, we're going to try to change the bottom margin. In this case, we are using the top and trying to change that thing because our image right here is already at the top of the screen. If we tried to increase the bottom margin and push this thing up further, the image itself would not move. It would be the container that has its bottom margin try to expand down here. So we'll try doing the bottom later on, but for right now we have to do the top to get the image to actually push down off the app bar. Now the final thing I want to mention here is that notice how we are referencing cat animation.value. So remember, the animation object itself is what is actually recording the current value that we are changing, or the value that we are trying to animate. So that value that is being stored inside of our animation object can be referenced through this value property right here. So that thing starts off with a value of 0 and then eventually ends up at 100. Now, before we test this out, one quick thing that I want to mention here, when I first started talking about animation with Flutter, and this is a really important thing, so hopefully I still have your attention somewhat. When we first started talking about animation with Flutter, you might have been thinking, oh yeah, we're gonna get some like widgets that magically takes a child and then like move them around the screen, and like that's going to be the animation system. But if you really take a close look at what we're really doing to animate this thing, all of our animation code around cat animation right here, it has, this is the key, it has no idea that we're trying to change the spacing or the positioning of an element. So when we start thinking about animation with Flutter, we're not thinking about widgets. We're thinking about values that we want to have change over time. In our case, we had said that we wanted to have some widget that's going to have a vertical positioning change. So rather than making a widget that said like, change my position, that's a part of the animation library over here. There's nothing over here that says change my position. Instead, we have to create an animation value that sort of represents a property that we want to change over time. In other words, the cat controller and the cat animation, it doesn't know that it is being used to change the spacing of a widget. All cat animation knows is that it's going to start off at 0, it's going to go up to 100, and that change is going to occur over the span of 2 seconds. That is all cat animation understands. So then at some point in time in the future, we make use of that animation to apply it to the margin of some widget. Again, the animation doesn't know what margin is. It doesn't know what a top property right here is. It doesn't know what a container is. All the cat animation knows is that it is a number that's going to change over time. So as you start to plan out animations for your applications, you need to be thinking about what property you're going to try to change over time, from some starting value to some ending value, because that is how we put our animations together. Okay, so enough of the lecture. Let's do an actual test here. So let's pull this thing up. I'll do my hot reload. We'll let that kick in. And then back over here, restart kicked in and nothing happened, which is totally fine. This is an error that I wanted you to see, or kind of a little mistake on our part that I wanted you to see, because this is something that I can almost guarantee that you're going to run to on your own projects in the future. So quick pause, and I'll tell you a little bit about why we are not seeing this cat move around the screen. So I'll see you in just a minute. In the last section, we refreshed our emulator, expecting the cat to kind of move around on the screen, but nothing happened. So like I said at the end of the last section, this is a kind of mistake I wanted you to see, because I really expect you to kind of run into this on your own personal projects. So first, I want to start off with a quick reminder back over here on this diagram. Remember, we'd been talking about that animation controller. And with the animation controller, we had said that the purpose of this thing is to start, stop, restart the animation. So we tried to refresh the simulator and we expected something to just happen. The animation is not going to start or begin until we look at that animation controller and tell it, hey, it's time to do your thing. It's time to kick into gear, start playing that animation. So to play our animation, we're going to go back up to our init state method right here. And underneath where we initialize cat animation and cat controller, we're going to look at our cat controller and we're going to call forward on it, which is going to cause our animation to start playing. Okay, so kind of a silly thing, but again, this is something that I think you might run into at some point, so I just wanted you to kind of run into that mistake together. Okay, so I'm going to save this file, and we'll try it out one more time. So I'm going to refresh it in the terminal. We'll wait 5 or 6 seconds for the refresh to kick in. And then over here, we saw that kind of ugly, not too attractive, but clearly that animation is kicking in. And so we go blah, 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 down from 100, 0 pixels of margin at the top, all the way down to 100. So there's our first animation. Good progress. Still got a lot of work to do. Let's take a quick pause right here, and we'll talk about some further stuff around animation. In the last section, we managed to get our cat to move around on the screen, or more specifically, we moved it down 100 pixels as soon as the application loads up. So now if I refresh the application again, after about a 4 or 5 second refresh, the app is going to reset, the cat goes back up to the top, and then over the span of 2 seconds, we see it kind of slide down just a little bit. So this is somewhat close to what we're aiming for. You know, the cat's definitely moving around. It's not moving in the right direction. And the other thing I want to mention is that the cat is moving the instant that our application starts up. So that's not really the experience we want. We had said originally, while looking at our mockup, that we want to make sure that the cat only moves up or down whenever a user taps on this box right here. So in this section, we're going to figure out how we can trigger that animation only when a user taps on the screen. To do so, we're going to be making use of a widget called a gesture detector. A gesture detector is a widget that specifically watches for physical feedback or physical input from the user coming from their fingers on the screen of the device. So that can take the form of a tap or a drag or anything similar to that. If you go down to the constructor function on the gesture detector class documentation, you'll see that there is a wide range of different callbacks we can pass into this thing's constructor. So we are not only limited to, say, a tap gesture, which is a single finger tap or kind of click on the screen. We can also set up callbacks on this thing for handling double taps or a long press or a drag down and so on. You get the idea. You can read through this list and get a better idea of how we can make use of this gesture detector. Now, when we create the gesture detector, we'll pick some number of different callbacks in here that we want to define, and then we will pass in a callback function to just those specific name properties. For you and I, we want to move the cat anytime a user just does a single tap on the screen. So we're going to create a gesture detector, and we're going to pass in a callback to the onTap name parameter. So let's give this a shot. Back inside my code editor, I'm going to go down to my build method. And then at present, for our body of the scaffold, we are calling build animation directly. I'm going to wrap this build animation with a new gesture detector, and then I will pass in the build animation to the gesture detector's child name property. So let's do that refactor. I'm going to say gesture detector, and then into that thing, I'm going to pass a child. The child, or the widget that is going to be displayed or essentially wrapped by the gesture detector, is everything that is generated by you and me calling the build animation method. So for the child, I'm going to say build animation. And then I'm going to also define the onTap callback. Rather than putting a function in right here, like a function literal like so, I'm going to instead create a helper method on this class that will be invoked anytime a user taps on this thing. So I'll call this helper method that we're going to add to the class. Let's just call it onTap, like so. So now right above my build method, I'll define that onTap helper function. And that's pretty much it. Okay, so interesting thing here to note, whenever we create a gesture detector, again, we're passing a child in. And so anytime a user taps on anything that is a child of this gesture animation or this gesture detector, that tap event is essentially going to bubble up until it gets to this gesture detector. So if a user taps on our box right here, well, the box is not the gesture detector, but that tap event on the box is going to sort of bubble up the widget hierarchy until it gets to the widget, the gesture detector that we just added in, and that will then trigger the onTap callback. So now inside of onTap, we'll say that rather than always starting our animation the instant that our application loads up, let's move the starting of our animation from our init state method. Let's move it into this new onTap callback, like so. So now when we refresh our application, the animation is not going to play right away. It's only going to play once the user taps on the screen, or essentially on the image of the cat. So let's try that out. I'll do a refresh. Wait 5 or 6 seconds. Okay, so now the cat is just kind of sitting here, but as soon as I click or tap on the screen, I start to see the cat slide down. Cool. Okay, so definitely a little bit of an improvement, but still a lot to do. So let's take a quick pause and come back in the next section. In the last section, we added in a gesture detector to our build tree. Now, anything inside of build animation right here, or any widget that is produced by build animation, if a user taps on anything produced by that method, the tap event will essentially bubble up to this gesture detector, and then the gesture detector will execute our onTap callback. Now at present, inside of onTap, we are calling our cat controller and trying to progress the animation forward. So essentially take this tween value from a starting value or a beginning value of 0 to the end state of 100. Now the downside to this whole approach is that once the cat ends up on the bottom of the screen down here, or kind of progress down the screen a little bit, we don't have any way to reset the state or the position of the cat without refreshing the entire app. I think it would be really neat if we could tap on this thing a second again and have that second tap kind of reverse the animation and bring the cat back up to the top of the screen. So to do so, we're going to look at some of the documentation around our controller or our animation controller. Remember, the cat controller right here is an instance of animation controller. So let's go look at the documentation for it very quickly. Okay, so again on the Flutter documentation, I'm looking at the animation controller class. And on the properties section over here on the right-hand side, I'm going to find a property called status right here. The status property tells us about the current state of the animation. So whether or not it is at the very beginning, where for you and me, our beginning value has 0.0, or if it's at the end of 100.0, or if it is somewhere in between. This status property that is present on the animation controller is always going to be equal to one of the values that are stored inside of this animation status class right here. So I'm going to click on animation status. And once over here, you'll see that it doesn't actually say it's a class. It's actually something called an enum. An enum is essentially a closed set of different values. So our animation status can only ever be equal to one of these 4 values right here: completed, dismissed, in a forward state, or a reverse state. So underneath each one of these statuses, you'll see a bit of text to describe the current status of the animation. So if our animation controller status is equal to completed, that means that the animation is at the very end and it is no longer doing anything. And so that would be equal to this state right here, where the cat is progressed all the way down towards the bottom or the middle of the screen. So essentially, to kind of reverse our animation, we need to look at the animation controller status property. We need to check to see if it is equal to either completed or dismissed. And then based upon which value it's equal to, we're either going to play the animation forward to move the cat down to the bottom of the screen, or we're going to reverse it to get the cat back up towards the top. So let's try writing out some code for that. Back inside of my onTap method right here, I'm going to add on an if statement. I'm going to look at the cat controller's status property, and I'm going to check to see if that thing is equal to the animation status dot completed property. So if the status is equal to completed, that means the animation is stopped at the very end, and we need to somehow reverse the animation back to its original state. So I'm going to say animation status dot completed. So if that is the case, then I want to reverse the animation. To reverse the animation, or essentially take our tween value right here from 100 backwards to the beginning value of 0, on the cat controller, we can call reverse. So the reverse method right here is the exact opposite of forward. Forward begins our animation playing and takes our tween value from a beginning value to the end value. Reverse is the opposite. It takes us from the end value back to the beginning value. So that's going to check to see if we need to reverse the play order of our animation. Now we're going to add in a second check. So we'll say else if cat controller dot status is equal to animation status. And in this case, we want to check to see if the animation has not yet even played. So we want to see if this is still in its initial starting state. To check that, we're going to check to see if the animation controller status is equal to dismissed, which means that the animation is stopped at the very beginning. So right here, animation status will say dismissed. And then if that is the case, then we are going to want to take our cat controller and progress the animation forward and go from a value of 0 up to 100, which is going to cause the cat to move down the screen. Okay, so that's it. I'm going to save this file, and then we'll do another quick test. So I will do a refresh over here. And then once it kicks in, I should now be able to click on the cat and watch it move down towards the middle of the screen. And then once the animation is completely done, I should be able to then click it again and see the cat go back up. Now the really important distinction here is that those two statuses that we just used of completed and dismissed are only checking to see if the animation is essentially in a non-changing state. So stopped at the end, stopped at the beginning. Those two statuses do not cover the cases in which it's currently running, either forward or backwards. So in short, if a user taps on this thing while the animation is still playing, so like right now I'm tapping as fast as I can, and you'll notice that it is not changing direction once the animation is playing. It waits until the animation finishes and then it reverses. If you wanted to allow the cat to change direction at any point in time, then you could add on additional checks to see if the status is equal to forward or reverse. And so that will allow you to kind of interrupt the current playing animation and send it back towards some other direction. But for you and me, we probably just want to have the cat try to go up or down after an animation has completely stopped. So I'm happy with how it is right now. Okay, so definitely good progress there. Let's take a quick pause and we'll continue in the next section. We've now done everything we need to get a cat to show up on the screen and move up or down whenever a user taps on it. So I think it's now time to start working on our box here a little bit. Remember, the box is going to consist of this main box shape right here, and then it's also going to have the two flaps off to either side. And at a kind of resting state, or when the cat is down inside the box, we want to see these different flaps over here on either side kind of like shake back and forth a little bit and just kind of essentially rotate about the box corner so that it looks like the cat is kind of messing around inside the box in some fashion. So let's try starting very simple and just get a box to show up on the screen. So I just want a plain box, some like brownish color, I don't know, and maybe we'll set some given height and width on it. So to get a box to show up, we're going to be making use of a container class. So I'm going to look up container inside my documentation again. And inside this container class, we can scroll down to the constructor as usual. And down here, you'll notice that it takes a color property. So this color property, if we provide it, is going to be used to color the entire internal area of the box. We can then supply a height and a width to the box as well, or to this container, and that will essentially accomplish what we're trying to do. It'll draw a big rectangle on the screen with some given color. So let's try putting this together. Back inside my code editor, I'm going to go down towards the bottom of this class. And at the very bottom, I'm going to make a new method that will return our container widget that's going to represent the box. And I'll call this method buildBox, like so. Then inside of here, I'm going to return a container. I'll give it a height of 200 pixels and a width of 200 pixels. And then I'm going to set a color on it as well. So for the color, remember, we're looking at the color property right there. So I'm going to say color is colors dot, and so this is a list of all the different fixed or constant colors we have access to. And since it is a box, I kind of want like a brown looking thing. You'll notice that on the list, yep, there is a color brown that we can easily get access to. Okay, so that's pretty much it. That is our box right there. So now we need to somehow show this box inside of our body of our entire widget. So at present, for our body, we're declaring this gesture detector. And inside the gesture detector, we are calling build animation. And so I think that it would make a little bit of sense to kind of like try to put the box somewhere around here, but you'll notice that essentially everything that we're working with right now is only accepting a single child. So in short, we have the ability to wire up a single child to the scaffold inside of the body. The gesture detector takes a single child, and then the animated builder will take a single child, and we really just get the opportunity to display a single child from there as well. So I think that we're going to need the ability to kind of stack up a couple of widgets together. Let's take a quick pause right here. We're going to come back in this next section, and we'll expand on this just a little bit more. In the last section, we added in our build box method, which produces a brown container, but it wasn't immediately clear where we could add that new widget into our existing hierarchy. Everything that we have inside of here right now only really accepts a single child widget. So again, not super clear where we're going to add this thing in. Well, let's take a look at a couple of diagrams that are going to help us understand how we can integrate the box into our current widget. Okay, so when we look back at our mockup, it's very clear that we need to have a collection of different widgets on the screen. And it's also clear that each of these probably is going to have a rather distinct location on the screen of the device. In other words, I always want this left-hand flap over here to be at the top left hand of this container that we had just created. And I always want this flap over here to be at the very top right hand as well. So to kind of precisely lay out these widgets in such a fashion, we're going to be making use of a layout widget. We've already used layout widgets in the past. So we made use of a column previously. Another type of layout widget is a row, and another type of a layout widget is a stack. So let's very quickly talk about the differences between all three of these. The column layout widget has pretty predictable behavior. We pass it a list of widgets. It's going to take all those widgets and attempt to lay them out in a column or a vertical fashion. A row is somewhat opposite. We give it a list of widgets, and it's going to render those all out in a horizontal list, or essentially in a row. Now the stack is very special. If you go back to our mockup over here, it's very clear that these 4 separate elements that we want, so flap 1, flap 2, box, and cat, really do not obey the layout of a row or a column. So for you and me, we're going to be making use of this stack widget. A stack widget allows us to more precisely lay out widgets on the screen. With the stack widget, we're going to give it a list of widgets, and then it's going to attempt to render them all directly on top of each other. And then we get the ability to kind of fine-tune or position those elements relative to each other. So in this case, it might look like the stack is only showing widget 3. In reality, underneath stack 3 is widget number 2, the green one, and underneath that is widget number 1, the blue one. So with the stack, we get everything stacked up on top of each other, and then we're going to do little nudges to kind of lay them out relative to each other. So with that in mind, I'm going to flip back over to my code editor, and we're going to add in a stack widget to our build tree. Let's take a quick pause right here, come back to the next section, and we'll add that thing in. In the last section, we spoke about how we can fix our layout issues by making use of a stack widget. So in this section, we're going to refactor our build method right here a little bit to add in a stack. Now at present, our gesture detector is always showing a single child of build animation. The build animation is really just responsible for building out the cat animation right now. So we're going to first begin by doing a little rename of this method to better describe its purpose. So I'm going to rename this thing to build cat animation, and I'll change the method name down here as well to build cat animation. not canimation, animation, there we go. Then as the child to the gesture detector, rather than providing that build cat animation, I'm going to instead provide it a stack widget. So I'll say this is going to be a stack, like so. Now the stack widget takes a array or a list of children that we assign to the name property of children. So this is going to be a list, and we're going to put all the different widgets that we want to show inside the stack inside this list right here. Now the order in which widgets are displayed inside of here, kind of, in other words, what shows up on top of each other, whichever widget we put earlier inside the list is going to be towards the very bottom, and then anything towards the end would be up at the top. So if we wanted to build this kind of stack right here, we would do something like widget 1, widget 2, and widget 3. Widget 1 is first, so it's at the very bottom. Widget 3 is last, so it's at the very top. So thinking back to our mockup over here, we're definitely reflecting the cat underneath the box, or essentially the box is kind of obscuring our view of the cat. So I'm going to put the cat down first inside this list, and then I'll add the box after it. And that's going to appear that the box is on top of the cat. So I'll get started by saying our build cat animation. And then after that, I'll call the build box that we just put together as well. Okay, so let's save this and do a quick test. So I'm going to do a refresh over here. Wait for that to kick in. And there we go. So we see our box, and it's definitely obscuring our view of the cat. Now, the layout definitely doesn't look too great right now. Like, yeah, you know, the cat's definitely underneath, but the box is up at the top left-hand side, and you'll notice that the box is definitely reflected towards the middle of the screen on our mockup over here. So let's take a quick pause. We'll come back to the next section, and we'll figure out how we can kind of get the box to be centered on the screen. In the last section, we added in a stack widget that got our box to show up in front of our cat. You'll notice that if I click on the box, the cat moves as well. And so this is our gesture detector in action. Anything that we provide as a child to the gesture detector is going to have a tap event watched. And so if we tap on anything that is inside the stack, our tap event that we assigned to the gesture detector is going to run. Now, we definitely made some good progress with the stack here, but you'll notice that back on our mockup, we are definitely reflecting everything as being in the very center of our screen. And so in this section, we're going to take a look at another layout widget that we can use to take everything that's going to show up inside of our current widget and try to position it towards the center of the screen. So for this, I pulled up the Flutter documentation of the widget catalog. Remember, you can get here by going to flutter.io/widgets. And then inside of here, I'm going to look for the layout section right here. So in the layout section, the first thing we see is single child layout widgets. If you scroll down a little bit, you can find multi-child right here. And so there's the row, column, and stack that we were just talking about 2 seconds ago. But in this case, we want to kind of position the entire stack on the very center of the screen. And so even though we have multiple widgets that we want to move, really it's multiple widgets that are all positioned inside the single widget of stack. So because we really want to move the stack and everything inside of it, we can instead make use of one of these single child layout widgets instead. And so in our case, we want to center the stack and everything inside of it at the very center of the screen. So we're going to be making use of this center widget right here. We can very quickly look at the documentation, but there's really going to be no surprise here. If you look at the constructor, essentially this thing is going to take a child. That's the widget that we want to try to center on the screen. So that's pretty much it. I'm going to flip back over to my editor. I'm going to find our stack widget right here, and I'm going to wrap this thing with the center widget. Now this refactor is going to be just a little bit tricky because notice how we're starting to get a lot of different parentheses to stack up here. So do take note of that. Make sure that you get in the right set or right number of parentheses. I'm going to first put a new line in. I'll say center. I'm going to open that thing up and add a comma at the end. And I'll say the child of center is going to be the stack. And so I'm going to take the stack all the way up to its closing parenthesis right there. I'm going to cut it, and I'm going to paste it onto the child of center. And then I'll save, like so. So we should now see gesture detector, center, stack, and we should see child, child, children. Okay, so let's give this a shot now. I'll go back over to my terminal. As usual, we'll do our Shift-R refresh. And then after that thing kicks in, we can see that it definitely, well, it kind of looks like it's getting towards the center of the screen. But if you noticed, when the page first loads, or the app first loads, it looked like the block was at the center, but then it kind of got shifted off to the left-hand side. So it feels like we're close here, but maybe we still have a little bit of work to do. So let's take a quick pause right here and continue in the next section. In the last section, we added in a center widget to our build method, but we noticed that it only looks like that box gets centered on the screen for like a split second when our application first loads. So like any second right there, and then it kind of flips over to the left-hand side as soon as the image loads up. So I'm really excited about this section because we're going to learn a lot more about how layout works inside of Flutter. And it's going to give us a better idea of what these layout widgets of center and stack are really doing for us. So we're going to spend a pretty good amount of time looking at some documentation to get a better sense of what's going on. We're going to first focus on the center widget and get a better idea of what that thing is doing for us. So over on the Flutter documentation, I'm still on the layout widget page. I'm going to go to the documentation for the center widget. If you already navigated away from that page, remember you can always go to docs.flutter.io and then search for center up on the top right. Now once you're here, you're going to see the answer to why we've got a little bit of an issue here, or at least kind of one half of what's going wrong, in the very first sentence of the center class documentation. So the overall description of this thing, it is a widget that centers its child. That's the keyword right there. Keyword is child within itself. So when we place a center widget on the screen, the widget is going to essentially expand to fill all the available space. So we can imagine that the center widget is spanning all the way from the top left-hand corner up here, all the way down to the very bottom right-hand corner down here. The center widget then takes a single child and attempts to center just that single child in that available space. So the child to the center widget right here is not the box and it's not the cat animation. The center, or the child to the center, is the stack. So it's the stack itself that gets centered on the screen. The positioning that is applied to the stack doesn't quite percolate down to the box or the cat. So just by using center on something that wraps the stack, we're not going to magically see the box get centered on the screen. The cat and the box are being laid out relative to the stack widget. That's why we see them on the middle of the screen right here, but that also explains why we're seeing the box off to the left-hand side. Whatever layout rules are being applied to the box and the cat animation are being applied by the stack, not the center. So let's now go take a look at the stack widget as well and get a better sense of how that thing works. And maybe that will give us a better idea of why the cat is kind of moving the box off to the left-hand side. Okay, so back over here, I'm going to do a search on the top right-hand side for stack. Okay, here's the stack class. And then what we're looking for is in the third paragraph right here. It says each child of a stack widget, so that would be our box and our cat, is either positioned or non-positioned. So right now, you and I are working with two non-positioned elements. That is our cat animation and the build box. These are what we refer to as non-positioned right now, or unpositioned. We'll talk about what a position widget is in just a second, but for right now, just understand that we're dealing with non-positioned elements. So here's the next important sentence. The stack sizes itself to contain all the non-positioned children. So that's the key sentence, and that explains why we are seeing the box kind of go off to the left-hand side anytime the image loads up. Let's take a look at a diagram that's going to give you a better idea of why that is. Okay, so in this diagram right here, I've got 4 different widgets essentially on the right-hand side, and we're going to apply these to the screen of our device one by one and get a better sense of what's going on. So the first widget that shows up is the center widget. Center widget. So the center is going to try to fill up all of the available space on the screen. So we can kind of imagine that that is the center. It's going to fill up everything that it possibly can. And then as a child to the center is our stack. so the stack goes on next. Now, the height and the width of the stack depends upon, so the stack sizes itself, so the height and width of the stack, it sizes itself to contain all the non-position children. So here's what happens when our application first loads up. The stack appears, and it kind of, maybe takes a guess as to how big, how wide, and how tall it should be. So maybe it ends up something like that. And then inside the stack, we put our container, which is a height of 200 pixels and a width of 200 pixels. And we'll say it's something like, I don't know, that right there. So the container then shows up inside the stack. As soon as the container shows up inside the stack is going to try to position itself to contain everything inside of it. And so we can imagine that the stack right here perfectly positions itself to wrap that container. And now you'll notice that I've got this like margin around the outside here. That's not what happens in reality. I'm just leaving the margin in there so you understand that the stack is like right behind the container like so. And so at this point in time, the center widget is saying, okay, I'm going to center that stack in the very center as best I can. And the center is going to the stack is going to attempt to wrap the container with itself. So now when the image shows up, that's where things get really thrown out of whack. So when the image finally loads up, because we are trying to fetch this image from over the internet, as we know, that image is really big. Like here's the original link for the image. It is taking up the full width of my browser. So this image is very, very large. When an image shows up on our device, it's going to try to fill up either the entire width or the entire height, whichever dimension is greater of the image. So in our case, we're working with an image that is very wide. So the image is going to try to span the entire width of the screen. And so we can kind of imagine that the ultimate width of the image is going to be something like that right there. Like this is the size of the image that we're trying to show. So that image then gets placed into the stack. So think about what happens when the image gets placed inside the stack. So the image goes like that. The image is a non-positioned element. It's a non-positioned child. So now the stack is going to resize itself to contain everything inside of it. So now the stack, which is green, we can imagine kind of grows out like that to contain everything inside of it. And now here's the key part. Remember, the center widget does not apply to the rectangle. The rectangle, or the container, the red thing right here, is just trying to position itself by default inside of the stack. And by default, here's the next sentence, by default, everything inside that stack is going to be positioned according to the alignment, which defaults to the top left corner of the stack. And so now that the stack has grown in width, this container right here is going to try to position itself by default on the top left-hand corner, or essentially off to the left-hand side of the screen. And that's why we're seeing this behavior right here. So the stack is correctly being centered. When everything first renders and the image is not here, the container shows up on the center of the screen. Oh, I clicked on it by mistake. The container gets centered on the very center of the screen, but then as soon as the image loads up, that resizes the overall width of the stack, and then the container gets repositioned to essentially the top left-hand corner of that stack. And that's why we're seeing it off to the left-hand side here. And technically, it really is at the top left-hand corner up there. Okay, so that's what's going on with the layout. Again, if this all seems confusing, the one key that I want to throw out there, the real understanding to all this, it would have been really hard to understand how all this stuff worked without reading the documentation. And so when you start working on your own projects, I can guarantee you, you're going to run into issues with layout. The best suggestion I can give you, read the documentation on the layout widgets that you're using, because they will give you little hints like what we just saw inside of here that perfectly explains the behavior of what's going on. Now there's one last little trick to help you understand layout that I want to show you very quickly. We're going to add just a little bit of code. Let's add the code and we'll talk about what it's doing. I'm going to flip on over to my main.dart file. So here's main.dart inside of my lib directory. Inside of here, I'm going to add a quick import statement. I'm going to say package flutter rendering.dart. And then inside of main, I'm going to say debug paint size enabled equals true. So this rendering file right here has a flag inside of it called debug paint size enabled, and we just flip that over to true. When we do so, it's going to add in some additional elements on the screen of our emulator that helps us get a better idea of how the layout is working. So if I now save this, I'll go back over to my terminal and refresh, and then back over inside the emulator. As soon as that refresh kicks in, you're going to see that there's a bunch of additional lines inside of here, and those are all going to help you get a better idea of how this layout is functioning. So it's really hard to see, but you can see kind of like the yellow lines right here. Those are constraints being provided on our layout by the center widget. And so the yellow lines are pointing from the center widget down to our stack. Inside the stack, we've got the line around the box right there. We've also got the line around the image, which is the inner line, the inner blue line right there. And then the overall stack is essentially trying to tighten as tightly, I guess, around everything inside of it as it possibly can. And so the stack is the outside line right there. It's on the outside because it's trying to constrain or wrap the entire box inside of here. And so this will actually give you a better idea of why the cat is showing up where it is. The cat as well is trying to show up on the very top left. The box, however, is taller than the cat, which is causing the stack, the bottom line right here, to show up as being taller or outside of the cat. So again, just a little trick right here that you can use to get a better idea of why your layout is working the way it is. Now, if you want to, you can leave this flag on. Personally, I'm going to take it out, and maybe at some time in the future, if we're working on another app where position is really critical, I might turn it back on, but I'll definitely let you know that I'm doing that. Okay, so long section, and maybe we've got a better understanding of layout, but it still did not really fix our issues here. So let's take a quick pause. We'll come back to the next section, and we'll talk about how we're going to fix this thing. So quick break, and I'll see you in just a minute.